This is Spacetime, Series 22, Episode 35. Coming up on Spacetime, the very fabric of space being twisted by spinning black holes, the strange star from out of town, and the first commercial launch of the world's most powerful rocket. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
Astronomers have witnessed a black hole twisting the very fabric of space-time by its rotation. A report in the journal Nature claims the black hole's powerful gravitational pull is literally dragging nearby space-time, causing jets of fast-moving energy and plasma being expelled from the area around the black hole to wobble so fast that their change in direction can be seen in periods as short as minutes. The authors were studying V404 Cygni, a stellar mass black hole about 9 times more massive than the Sun, located about 8,000 light-years away. V404 Cygni first came to astronomers' attention back in 1938, when it experienced an outburst and got its initial designation as a variable star. Another outburst was observed in 1989, and follow-up studies revealed a previously unnoticed outburst in 1956. NASA's Swift Space Telescope detected the latest outburst on June 15, 2015, triggering a worldwide observing effort. The authors made their observations using the National Science Foundation's Very Long Baseline Array of radio telescopes. The array began its observations on June 17, 2015, and continued for almost a month through to July 11. They found the black hole was drawing in material from a companion star, with a mass about 70% that of our Sun. Now, as material streams towards a black hole, it forms a rotating disk called an accretion disk surrounding the black hole. And this accretion disk becomes denser and hotter with decreasing distance from the black hole's event horizon, the point of no return, beyond which material will disappear in the black hole, falling forever towards the singularity. But some of this superheated material on the accretion disk can escape before reaching the event horizon, travelling along magnetic field lines to be shot out as microquasars. And the material being ejected from V404 Cygni is travelling at some 60% the speed of light. However, the astronomers noted that the black hole's rotational axis is precessing, possibly because of the gravitational pull of the companion star upon which it's feeding. And so the jets aren't stable, but instead rapidly wobble. The study's lead author, Associate Professor James Miller-Jones from the Curtin University node of the International Centre for Radio Astronomy Research, says he's never seen an effect like this happening on such short timescales. Such a rapid wobble has simply never been seen in such systems before. The phenomenon can best be explained when viewed through Albert Einstein's general theory of relativity, which shows how massive objects, like black holes, distort the very fabric of space-time, giving the effect we all know of as gravity. And as such massive gravity wells as black holes spin, their incredible gravitational influence pulls space-time around with them through an effect known as frame dragging. In the case of V404 Cygni, where the black hole's spin axis is misaligned from the plane of its orbit with the companion star, that causes the frame dragging effect to warp the inner part of the disk. Then pull the warped portion around with it, which changes the orientation of the jets, producing the wobbling effect observed by Miller-Jones and colleagues. Miller-Jones says it's the only mechanism he can think of that explains the rapid precession seen in V404 Cygni. He says you can think of it as the wobble of a spinning top as it slows down, only in this case the wobble's caused by general relativity. While V404 Cygni's accretion disk is about 10 million kilometres wide, Miller-Jones points out that only the inner few thousand kilometres or so is warped. And that inner part is also puffed out by strong radiation pressure into a donut shape that precesses like a rigid body. Interestingly, the jet's rapid direction changes also meant that the authors had to change their observation strategy. See, normally astronomers would produce a single image using data collected over several hours, very similar to a long-term exposure. However, these jets were changing so fast that in a 4-hour image, all they really got was a blur. So to capture the rapid motion, the authors made 103 individual images, each about 70 seconds long, and then combined them to make a movie. Miller-Jones says similar behaviour would be occurring in other black hole systems. It just hasn't been documented at this rate before. He says the discovery will therefore deepen science's understanding of the physics of black holes and the environment surrounding them.
This is a very exciting black hole system that we've been looking at. It went into a very bright outburst. So the black hole started feeding very rapidly in June of 2015. And we looked at it with the National Radio Astronomy Observatory's very long baseline array. So this is a very high-resolution radio telescope. It's made up of 10 dishes spread across the US from Hawaii to the Virgin Islands. And that allowed us to zoom in to see the details of the jets that were being launched by the black hole and how they were evolving. So when we looked with this telescope at this rapidly feeding black hole, we saw something fairly unexpected. So we saw that instead of moving in a single direction, the jets appeared to be moving in different directions at different times. And that's never been seen before, at least not on this very short time scale. So within a single 4-hour observation, we saw that the jets were moving out in different directions, and we had to try and figure out why that was occurring. The black hole in V404 Cygni is only about 9 times the mass of the Sun, so it's not a particularly big black hole in the grand scheme of things. The supermassive black holes that you find at the centers of galaxies are millions of times bigger.
We shouldn't consider these quasars then?
No. They're something that we call microquasars. So
okay.
Black holes are very simple objects. They have a mass, a charge, which is usually 0, and a spin. And so the physics around black holes should be very similar, whether you're looking at one of these fairly small black holes, just a few times the mass of the Sun, or one of these supermassive black holes in quasars. So we see the same kind of physics around both types of black holes, but because these ones are scaled down, they're sometimes called microquasars.
Okay.
So the jets in this one, we saw on a size scale probably about the size of our own solar system, and that was the kind of scale to which we could zoom in with our radio telescope.
Was this a rhythmic thing, this wobble you were seeing, or was it more staccato than that?
We think it was probably more staccato. So we could only see the jets moving out when they emitted the brightest bursts of energy. So these jets are carrying a huge amount of energy away from the black hole at speeds we measured of about 60% of the speed of light. So they're really powerful, very energetic things. But we only saw the very brightest ejections of energy. And so we saw about 12 of these over a 4-hour period. And so we couldn't, with only those 12 ejections, we couldn't say exactly whether they were swinging around regularly or not. But our explanation for what's going on suggests that this is much more likely to have been a bit of a staccato type scenario where it's not a rhythmic wobble as we've seen in some other systems on much longer timescales.
Like neutron stars, yeah.
Yes, and also a system called SS433, which is a very well-studied system where we see swinging jets that describe a corkscrew pattern on the sky. Mm-hmm. In that system, the jets are swinging around on a timescale of about 6 months. In this case, we think it was a timescale, well, it was certainly less hours, if not minutes. So that's thousands of times faster, and so we needed a different physical mechanism to actually cause this.
What do you guys think's doing it?
So what we think is going on is that we think that the black hole is spinning, and we think that it's spinning around an axis that is different from the axis of the orbit of the companion star. So this black hole is feeding on a companion star. It's in a 6.5-day orbit with a star that's about 70% of the mass of our Sun, and the outer layers of the star are being pulled off and falling in towards the black hole. So we think that orbit is around a different axis to the spin of the black hole. So that means that when the material gets close to the black hole actually, because of its strong gravity, Einstein's theory of relativity tells us that it pulls space-time around with it. And so this means that the gas is forced to move around in the direction of the spin of the black hole. But there's a region, therefore, where the gas has to go from rotating in one plane as it swirls around the black hole in a disk to rotating along with the black hole itself. Because the black hole was feeding very rapidly, that the intense radiation that it was generating puffed up the inner few thousand kilometers of the accretion disk, the disk of gas that's swirling around the black hole. So this whole disk is about 10 million kilometers across. Just the inner few thousand kilometers was puffed up into a sort of a donut shape, if you like. And we think that because of the misalignment between the orbit and the black hole spin, that donut was being forced to precess, so basically wobbling around an axis, much like a spinning top would as it slows down. And we think that precessing inner part of the disk was actually pulling the jets around with it, and that was what was causing the redirection. So it's a very exciting demonstration that what's going on these very, very small scales right down at the black hole is affecting the jets on much larger scales out to the size of the solar system.
That's Associate Professor James Miller-Jones from the Curtin University node of the International Centre for Radio Astronomy Research. And this is Spacetime. I'm Stuart Gary. Astronomers have discovered a star in the Milky Way with a chemical composition unlike that of any other star in our galaxy. A report in the journal Nature Astronomy found that the chemical composition of this strange star, which has been named J1124 plus 4535, had previously only been seen in a small number of stars in dwarf galaxies orbiting around the Milky Way. Now, this suggests that this star may once have been part of another galaxy, a dwarf galaxy that had merged into the Milky Way millions, or more likely billions of years ago. The star was identified in the constellation Ursa Major, the Great Bear, as part of the Large Sky Area Multi-Object Fiber Spectroscopic Telescope survey. Scientists noticed the star by its unusual spectroscopic chemical composition. You see, initial observations showed that it had low abundances of elements such as magnesium. And follow-up observations using the high dispersion spectrograph on the Subaru telescope confirmed the low levels, but also found comparatively high levels of another element, europium. It's the first time an element ratio like this has been observed in any star in the Milky Way. Stars are formed through the collapse of molecular gas and dust clouds, and the ratio of the different elements in that parent cloud impart an observable chemical signature on the stars formed in the cloud. So, stars formed close together have similar element ratios. The fact that the composition of J1124 plus 4535 doesn't match any other stars in the Milky Way indicates that it must have formed elsewhere, in another galaxy. And when you look around at some of the stars in satellite galaxies orbiting around the Milky Way, you can find similar chemical compositions. And this all fits in really nicely with our models of galactic evolution. Simulations suggest that galaxies like the Milky Way grow by absorbing neighbouring satellite dwarf galaxies, a process called galactic cannibalism. It's happening all the time. Right now, the large and small Magellanic Clouds are having gas and stars drawn off them onto the Milky Way. And on the other side of the Milky Way, another galaxy, the Sagittarius Dwarf, is in the process of being totally consumed by the Milky Way. Thus, it makes perfect sense that the star J1124 plus 4535 was born in a now vanished dwarf galaxy, which sometime in the distant past merged into our Milky Way galaxy. And of course, in 3.7 billion years or so from now, the Milky Way itself will suffer a similar fate when it gets cannibalized and absorbed by the much larger Andromeda galaxy M31. I'm Stuart Gary. This is Spacetime. Blue Origin has carried out another successful test flight of its new rocket system designed to carry tourists into space. The company's latest suborbital test flight from their West Texas launch pad reached an altitude of over 106 kilometers, some 346,406 feet. That's well above the 100-kilometer high Kármán line, which marks the internationally recognized official start of space.
We're getting ready for New Shepard's 11th mission to space, known by Team Blue as NS-11. The clock is at 19 minutes and 50 seconds until liftoff here, ticking down to what should be another exciting launch. Now, the rocket that's out there on the pad, she's getting ready for her 5th launch to space and back. That, guys, is a reusable rocket. That rocket has 38 payloads on board. That is a record for us on New Shepard. Why don't we get into the profile of today's test? Capsule is going to continue up over 100 kilometers. That's when you're going to get 3 to 4 minutes of zero-G freedom, taking in those beautiful views. And then the capsule, of course, will come down under the parachutes and retrothrust system that will create the air cushion just in the last milliseconds. The booster itself, of course, will continue up to its own apogee and come in for a nice soft landing just 2 miles north of where it's taken off from. Now, that capsule will continue to be used for payloads. The newest capsule that's going to be flying humans later this year, it's in the barn, not too far away from me. And because it's such a special capsule to us, we actually decided to name the newest capsule that's just in the barn the RSS First Step. RSS, reusable spaceship, of course, right? And First Step because it is our first capsule that is going to be taking people. It's going to enable our vision of millions of people living and working in space. So cool, right? All right, the bridge is retracting. Guys, we're about to launch a rocket. Let's turn it over and listen in on pad audio as New Shepard comes alive for space. New Shepard at this point completely autonomous, starting at T-minus 2 minutes. Man, I have said this before, but there's nothing like a ticking clock and a rocket behind you to get your heart going. Guys, it's time to go to space. Let's get ready to rumble, New Shepard. Next milestone here, MECO, main engine cutoff. The engine's going to cut off, but it's going to continue its ascent to space, both the booster and the capsule together. Main engine cutoff is confirmed. The separation is confirmed. Still accelerating up. We passed the Kármán line, the internationally recognized line of space. That's at about 330,000 feet. And we've hit apogee. You see now that the speed went to 0. It's now speeding up again as the craft are coming home. Unofficial altitude, 344,000 feet or so. All right, right about now, the rocket itself is going to hit what we call atmospheric pierce point. It's coming back from space into the atmosphere. It means it has air pressure for some of those aerodynamic surfaces to push against so it can maneuver itself. First of the subsystems to support the stability of the rocket, the wedge fins, we have confirmation that they have been deployed. All right, at about 12,000 feet, there that goes. Drag brakes as the speed of the rocket dramatically is reduced. And we're going to wait for the BE-3 engine to relight and bring her down for a nice soft landing. Boom, we felt the sonic boom here down in Texas. Look at that beautiful hover. And touchdown. Amazing, beautiful. Look at those wedge fins retracting, and there go the drag brakes as well. Her work is done. 5th flight to space and back for that rocket. Just incredible. Congratulations to the Blue Origin team on that. Just another beautiful flight to space and back. All right, well, show is not over. All eyes are on the capsule now with those 38 payloads. There go the drogue chutes. And there are the mains, a bit of coning, but that is all right. Reefed and now full inflation of the parachutes. Picture perfect. I can see the capsule from here just off in the distance. Nice and stable descent. A nice stable descent. See, it's 15 miles an hour. Last milliseconds, we're going to get the retrothrust system that's going to fire. It's going to kick up the dust. But that's a nice air cushion for the payloads. I see our team has already left our center here. It's going off to recover the capsule, and there it is. Touchdown. A beautiful, beautiful launch and landing of the booster and the capsule today. Incredible.
The flight, which reached a maximum speed of 3,500 kilometers per hour, was the 11th test flight in the company's program, which should see it carry its first people into space by the end of this year. But the Jeff Bezos-owned company is yet to sell tickets or even set prices for prospective space tourists. Once passenger flights begin, capsules carrying up to 6 people at a time will undertake the ballistic straight up and straight down again 11-minute flights, providing spectacular views of planet Earth from space through giant panoramic windows and the experience of several minutes of weightlessness before returning to the surface for a parachute landing. As with previous test flights, numerous scientific payloads were installed in the reusable capsule for the flight. The 28 research payloads in the mission included 9 for NASA as part of their Flight Opportunities program, including a new 3D printing experiment and a payload testing how space dust behaves in microgravity. Numerous experiments by school children were also flown on the journey. Blue Origin's main competitor in the space tourism market for now is Virgin Galactic. But the Richard Branson-backed company is still well behind the 8-ball, following a fatal mid-air breakup during a test flight in 2014. And the company's rocket-powered winged spaceplane is yet to achieve an altitude of 90 kilometers, still well below the Kármán line. However, they have already worked out a price for each ticket, a juicy $250,000 US. I'm Stuart Gary, who hasn't got a spare $250,000. This is Spacetime. SpaceX has successfully carried out its first commercial flight using its new Falcon Heavy launch vehicle. The flight carried the Arabsat 6A telecommunications satellite into geostationary transfer orbit from Pad 39A at the Kennedy Space Center at the Cape Canaveral Air Force Station in Florida.
Vehicle flight pressures.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 0. Ignition. Liftoff.
Under the power of 5.1 million pounds of thrust, Falcon Heavy is headed to space. We're throttling down at T plus 40 seconds to prepare for maximum dynamic pressure.
Power and telemetry are nominal.
Vehicle supersonic.
Side boosters are throttling back up on power as we're through the period of maximum dynamic pressure. Trajectory looking good. You can hear the applause behind me as we've gotten past maximum dynamic pressure. Next event coming up is chill-in of the MVAC-D engine. Get the turbo pump ready to ignite the main engine on the second stage. Merlin engine performance looks good. We've begun dropping power on the side boosters to decrease loads on the center core.
Second load limiting shutdown.
Continuing to decrease loads to minimize acceleration on the Falcon Heavy structure.
MVAC engine chill.
Pico.
Booster separation confirmed.
Successful separation, if you can hear me over the cheering. Side boosters now beginning a flip to begin returning back to Cape Canaveral. Side boosters have begun the boost back burn. The center core has throttled back up to power. Everything looking good on the flight of Falcon Heavy.
Miko.
Main engine cut off. Center core shut down.
Separation confirmed. MVAC ignition.
Again, over the cheering. MVAC-D engine up on power. It looks good. Side boosters looking good. Still burning on their way back to Cape Canaveral. Grid fins are out on the center core.
Fairing separation confirmed.
Here comes the fairing separation, and there it goes. We also have successful shutdown of the side booster boost back burn. Side boosters on their way back to Cape Canaveral. Center core coasting out over the Atlantic.
Nominal.
Stage 2 looking good with a nominal trajectory.
The grid fins have deployed on the side boosters as well as the center core. Those work to help guide the boosters back to a nice targeted soft landing. As a reminder, today we'll be attempting to recover all three of the first stage cores, and all three boosters are currently on their way heading home. In just a few minutes, the side boosters will execute an entry burn followed by a landing burn, and the center core will do much the same a few minutes later. Both burns are meant to slow the stage's speed down rapidly before landing.
At the time of separation, the side boosters were traveling slow enough to turn around and make their way back to land at our side-by-side landing pads. The center core, on the other hand, is going too fast to efficiently return to the Cape, so we're using our autonomous drone ship, Of Course I Still Love You. If we have a successful landing today, the side boosters will be reflown on our next Falcon Heavy mission, STP-2. Now, coming up at about T plus 6 minutes will be the side boosters re-entry burn.
Acquisition of signal Bermuda.
Side booster entry burn has started.
And there's the re-entry burn beginning.
Stage 2 trajectory nominal.
And the re-entry burn is complete for the side boosters. Now, coming up in about 30 seconds, the center core will begin its re-entry burn.
Stage 1 entry burn has started. Side boosters are transonic.
The re-entry burn for center core has begun. Coming up in about 5 seconds here, the side boosters landing burn will begin as well.
Side booster landing burn has started.
You can see the side boosters coming down. An amazing view. You can hear our crowd going crazy right now. Both side boosters has landed on our landing pads. Zone 1 and Zone 2. What an amazing sight to see.
Now we're waiting for the engine to shut down on the second stage and for the center core to land. Now, if all goes well, we'll have successfully recovered all three boosters, which we have never done before. Now, coming up in about 20 seconds, we're going to listen for confirmation of SECO 1, or second engine cutoff 1.
Ship AOS. MVAC shutdown.
And we have confirmation.
Center core
now we're
is
just waiting to hear good orbit.
Nominal orbit insertion.
And we have that confirmed. Good orbit.
The launch had been delayed by a day due to upper-level winds. Built by Lockheed Martin, the fully fueled 6,000-kilogram Arabsat-A is brought around an LM2100 satellite bus. It's fitted with a suite of KY and Ka band transponders to provide television and radio broadcasting, as well as internet access and mobile telecommunications across the Middle East, Africa and Southern Europe. It's also equipped with S, X and C-band transponders. The 70-metre tall Falcon Heavy is designed to lift 63.8 tonnes into low Earth orbit, 26.7 tonnes into geostationary transfer orbit, and 16.8 tonnes on missions to Mars, making it the most powerful launch vehicle operating today. Falcon Heavy uses 3 Falcon 9 core stages mounted side by side, with the center core carrying the upper stage and payload, while the 2 outboard cores act as gigantic strap-on boosters. You may recall the rocket's maiden flight back on February the 6th last year launched SpaceX boss Elon Musk's little red sports car into a trans-Martian orbit as a dummy payload. For this latest mission, the Arabsat 6A was correctly delivered into its orbit. And all 3 of the core stages returned to Earth safely, with the 2 booster cores landing side by side in spectacular fashion on the twin landing zone pads at the Cape Canaveral Air Force Station, while the center core landed minutes later aboard the SpaceX drone ship Of Course I Still Love You, which was pre-positioned downrange in the North Atlantic Ocean.
Now, coming up here in about 15 seconds will be the center core landing burn beginning. So again, as we mentioned earlier, this is going to be a challenging landing.
Stage 1, landing
and we are
starting.
landing on our drone ship, Of Course I Still Love You. Waiting for some confirmation, and it sounds like we landed the center core on our drone ship. We have landed the center core for the first time on our drone ship, Of Course I Still Love You. For the first time, we've landed all 3 boosters for Falcon Heavy. What an amazing day.
However, heavy seas later during the return voyage of the drone ship caused the center booster to topple over. The Falcon Heavy's next mission, slated for June the 3rd, will carry an evaluation payload of 25 small spacecraft as part of the US Air Force's National Security Space Launch Certification process. Secondary payloads will include numerous additional small satellites, as well as the Planetary Society's latest light sail, the LightSail 2, a kite-shaped solar sail designed to deploy and fold out into a total area of some 32 square meters. When the sun's just right, its glint should be visible from the ground. And time now to take a brief look at some of the other stories making news in science this week with a science report. Climate change is forcing coral reefs to move further away from the equator towards the poles. The findings, reported in the Journal of the Royal Society Open Science, was based on long-term fossil records of reef movements, allowing scientists to accurately predict reef migration. Before this study, predicting the effects of climate change on reefs was difficult because researchers generally only had access to short-term observations. But the current study made great strides by using fossil records to gain a longer-term view. Scientists found historical reefs moved towards the poles and declined at the equator as temperatures rose, much like what's happening now. Now, although movement towards the poles has happened before, the researchers note that these fossil records do not account for modern man-made threats such as ocean acidification, overfishing, other biodiversity risks, and of course the fact that man-made climate change is happening much quicker than what would have occurred naturally in the past. Scientists have devised a new decoder that can transform brainwaves into speech. Now, this has been done before, but the new device is much faster than those currently used by patients with neurological conditions who have lost the ability to speak. The new device, reported in the journal Nature, is a brain-computer interface that can synthesize speech using the signals that control lip, tongue, larynx, and jaw movements, even producing speech when participants silently mime sentences. The new interface brings science a step closer to the idea of a brain prosthetic that can restore speech function. A new study casts doubt on the widely accepted notion that spending too much time online, gaming or watching TV, especially before bedtime, can damage a young person's mental health. The findings, reported in the journal Psychological Science, are based on data from more than 1,700 teenagers, finding little evidence of relationship between screen time and well-being in adolescence. The study included data from 5,363 young people tracked under the Growing Up in Ireland project, 709 teens compiled by the United States Panel Study for Income Dynamics, and 11,884 adolescents surveyed as part of the Millennium Cohort study in the UK. A near-year-long experiment in astronaut twins, Scott Kelly, who lived in space for a year, and Mark Kelly, who stayed behind on the ground, has provided scientists with valuable insights on the health effects of living in space. The findings, reported in the journal Science, suggest that during Scott's time in orbit, changes occurred to genes affecting his immune system, his DNA expressions, his cognitive abilities, and even the shape of his eyeballs. While 90% of his immune-related genes return to normal after 6 months, it's unknown how long other changes will continue to affect Scott. New research suggests that women may have a better poker face than men when it comes to hiding an affair. A report in the Royal Society Open Science Journal suggests it's easier to spot adultery in a man's face than a woman's. It seems participants were more likely to judge a man's face as unfaithful if he had more masculine features such as a wider face. You see, masculine faces have been linked to higher levels of the hormone testosterone, which apparently makes men more likely to take risks and cheat on their partners. Researchers say women may have developed these cheat radars as a way of spotting a cheating partner. 2 so-called natural healers who used an Amazonian tree frog poison in their treatments have been banned from operating in Victoria and South Australia, while investigations continue into the death of a woman who had used the same frog poison interstate. The pair, both from South Australia, have been ordered to immediately stop providing their Cambo-based treatments. Cambo is a name for the skin secretions of the giant green monkey tree frog, which is found in South America's Amazon rainforest. Tim Mendham from Australian Skeptics says it's used in so-called cleansing rituals and has become popular as an alternative treatment, spawning a growing underground community of users.
This is basically some cure-all natural treatment that comes out of the Amazon where people scrape, in this case, the legs of frogs called the giant monkey frogs or something, or giant leaf frogs from the Amazon, and it's now being picked up here. Basically, what you apparently do is you burn some holes in your skin, or the practitioner, the shaman as it often is, burns some holes in your skin with a pointed stick. That's off to a bad start. Scrapes the legs of this frog and then takes off this stuff called Cambo, which is a waxy substance, and then puts it into the holes. And that's supposed to cure all sorts of weird and wonderful things, everything from basically not feeling too good to Alzheimer's and Parkinson's and cancer, infertility, and you name it, and to bring you luck. But apparently it didn't bring luck to some people. There's a practitioner, actually, of this treatment in northern New South Wales, of all places, who apparently, and they're not quite sure, died of this treatment. It can cause, starting off with just itches and that sort of stuff, but it can actually lead to some pretty serious side effects, including epilepsy and possibly death.
What does it do to the poor frog?
It just scrapes them, but then what's happened lately is there's a couple of practitioners who work in Victoria and South Australia. Because of this death up in New South Wales, they've now been banned from practicing this particular treatment, at least for a while anyway, until people look into it to see how dangerous it is.
This is one of those things, I guess, where there's been no real scientific evidence to support the claims being made. It's all hearsay, it's all placebo, and these individuals are just making money off gullible people.
I'd say so. I think that's the very sad thing, that people may often be coming to the people with practitioners with some serious complaints, but I think it's a folk cure and not much more than that.
That's Tim Mendham from Australian Skeptics. You're listening to Spacetime. I'm Stuart Gary, and that's the show for now. You can subscribe and download Spacetime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.